welcome to a little video about Target 5B. We are going to be constructing and interpreting two-way frequency tables and also taking a look at conditional probability. Now, with the first two-way frequency table, I'd just like to interpret it, and then I would like to do some conditional probability with the next problem. So we're going to skip one of these first ones. All right. I'll talk about the equation for conditional probability when we get to the second problem. First, let's take a look at this two-way table. We had a survey asking students, have they been to Canada? Have they been to Mexico? First, I'd like to ask you, how many students have not been to Mexico? This means I want to see the total amount of students who have not been to Mexico. Now, that's the second row. I'm going to go all the way down to the right, and I have a total of 16 students who have not been to Mexico. Now, I get that from right here. That's a bizarre thing. Why didn't my 6 work? Oh well. Next, I want to ask you, how many students have been to Mexico and not to Canada? All right, so have been to Mexico is my first row, and have not been to Canada is my second column. So we end up here at 3. Ooh, the next one is asking us about probability. So we're going to have a fraction in our answer. What is the probability of choosing a student who has been to Canada? So I'd like a total of those students. That's the first column. If you look at the very bottom, total of 11 students have been to Canada. Perfect. I'd also like to know, what's the total amount of students surveyed? You can always find this in a two-way table at the very corner at 25. So 11 out of 25 students have been to Canada. Now, lastly, I'd like to look at this portion of the problem. What is the probability of choosing a student who has been to Mexico and Canada? Right, well, let's take a look at has been to Mexico, that's first row. Has been to Canada, that's first column. They meet right there. 6 out of a total of 25 students have been to Mexico and Canada. I don't know why my 6 didn't turn out again. Does OneNote have something against my 6s today? Yeah. There we go. I'm not going to do this next problem because it is for our conditional probability, so I'm going to look at the next one about conditional probability with you. Now let's talk about conditional probability. This is a probability of event A happening given that B already occurred. And they're always written like this. B, then a slash of A, and we look at probability of A and B over the probability of A. So, let's take a look at these problems for this next chart. Okay, so we have a chart about attending soccer camp for 6th graders, 7th graders, 8th graders, and there's a separation for boys and girls. Let's use this table. We have the probability of 8th graders and girls. So let's see. This is our B. This is our A. Oh no. Bad OneNote. There we go. Good OneNote. All right. So let's write this out using kind of this form that I gave you here. So this means we have the probability of girl and 8th grader over the probability of a girl. Okay, so let's find the probability of a girl being an 8th grader. Okay, girl is the second row, 8th grader is the third column. That would be 12. Girls are 8th graders out of 50 total. So that's the fraction that I'm going to put there. Instead of doing a fraction within a fraction, I personally prefer to write it as a division symbol. Now, the second fraction we need to find is the probability of a girl being chosen in general. Well, the total amount of girls is 27, and there's a total of 50 soccer players. So, 27 out of 50. When we divide fractions, I'd like to remind you that it ends up being multiplication by the reciprocal. OneNote is not liking this document for some reason. Oh, there we go. Good job, good job. Okay. We will cross off those 50s because they reduce. And then we can actually reduce 12 over 27. I'm going to do that separately. That reduces to 4 over 9. So that is our probability of picking a girl given they're an 8th grader. Okay, wonderful. Let's switch that around. What if we're looking for the probability of an 8th grader given that they're a girl? How's that going to look different? Well, let's check it out. This is now our B and this is our A. Once again, I'm following the formula that's up here. And I love to label. So let's get to it. We'll write it out in English. We have the probability of an 8th grader and a girl over the probability of an 8th grader. Okay, let's do it. The probability of an 8th grader and a girl, once again, we have the second row, third column. That's 12 out of 50. I'm going to divide it by the probability of an 8th grader happening in general. Okay, well, let's take a peek. We have a total of 22 8th graders out of 50. So 22 out of 50. We go ahead and divide that. Just like in the previous problems, our 50s end up canceling. We get 12 out of 22, which I happily reduce to 6 over 11. Let's try it one more time, okay, with boys, given they're 7th graders. Let's do this one. This is A, that's B. So we're looking at the probability of 7th graders, given that they're, I almost wrote girls. I almost did it again. Oh my goodness, Miss Gumin. Given that they're boys. Over the probability of choosing a 7th grader. Okay. Let's see. 7th grader and boy. Boy is the first row. 7th grader is the middle column, so that gives me 6. 6 out of the total of 50 campers. And 7th graders, the total amount of 7th graders that we have out of the 50, that's our middle column, is 13. 13 out of 50. Oh, I chose the wrong color. Oh, 13. Okay. We get an answer of 6 over 13. Luckily for us, we cannot simplify any further. Okay, not too bad. You just got to be very careful with the format. I love writing everything out, so I highly recommend you do the same. Next, let's do a little bit more of a challenging thing and fill out a two-way table on our own. Okay? Okay. So, I'm going to fill in this two-way table using only addition and subtraction. Okay, here we go. The first thing I look at is these totals. 407 plus something gives me 831. I do some subtraction. Let's zoom in. Clearly, I cannot write without zooming in. I do some subtraction, and I get that there were 424 girls here. Okay. I'm going to continue this. I see another vertical thing I can fill out. Something plus 123 is 256. I do some subtraction, and I get 133. And I think I'm done with my verticals now. Let's take a look at my horizontals. Okay, so on the bottom, if you take a peek, we could do 303 plus 256 plus something is going to give us 831. So we need to do some subtraction. I subtract, and I get 272 11th graders. That gives me an opportunity to find out how many girls are in 11th grade. 125 plus something gives me 272. So I do 272 minus 125. I get 147. I know, there's so much. We're almost done. We just got to find out the 9th graders. And we can do that by looking, again, horizontally. I can find the 9th grade boys by doing this. 407 minus 125 minus 133, which gives me 149. And I can do the same thing over here. Something plus 123 plus 147 gives us 424. So 424 minus 147 minus 123 gives us 154. Okay. Wow. Now you might have filled this out a little differently than me. And you know what? That's totally fine. We should have still gotten the same values. Now where the challenging part comes in is being given no values, blank to a table. Let's do a little bit of a challenge. I like this one better, so we're going to do this one. I'm given a Venn diagram about students who have seen eels and octopuses, or octopi. I'm going to label my table first, and then I'm going to fill it in based on the diagram. Now, what I like to do is I take the right circle of the Venn diagram, and I'm going to put it on the top row. And bear with my handwriting. Octo, or octopus, yes, we have seen it. Or octo, no, we have not seen an octopus. And this is total. Then I'm going to take the left-hand side of my Venn diagram and put it in the vertical. So we have eel, yes, eel, no, and total. Okay, let's do this. Now the first thing that I think stands out to me personally is the middle of the Venn diagram, and that is where students have seen both an eel and an octopus. So that's my 8. So that should be octo, yes, eel, yes. So that's right there. Let's write it in. Okay, next I look at the circles of the Venn diagram, but the numbers that are not overlapping. I have a 6 in my right-hand circle. This actually tells me that 6 students have seen an octopus. They haven't seen an eel. So it should be octo, yes, eel, no. And that's right here. The other number is here for the eels. And that means those students have seen eels, but they have not seen octopuses. Octopi. I keep saying octopuses. Oh my goodness. So that should be eel, yes, octopus, no. So that goes right there. We really only have one other place left to fill in, and that is here. Octo, no, eel, no. And we find that number outside. They have not seen octopi, they have not seen eels, so they are outside of the Venn diagram completely. All we have to do now is add. I'm first going to add across. 8 plus 23 gives me 31. 6 plus 7 gives me 15. Now I'm going to go up and down. 8 plus 6 is 14. 23 plus 7 is 30. 31 plus 15 is 44. Just to double check, does it work across? 14 plus 30, yep, 44. Okay. I hope you found this helpful. If you have any questions, please don't hesitate to reach out to me. Happy to help with anything. Have a good rest of whatever day it is for you. Bye.